Hello. So here's just a quick note about using density as a conversion factor. So I have some stuff over here, right? Who knows what we want to call it? Do we want to call it a compound? Do we want to call it an element? Do we want to call it a mixture? Here we have a compound and we have two elements, but we have stuff, right? And that stuff's going to have a density. So water at 4 degrees Celsius is 1.00 grams per milliliter. Aluminum is 2.7 and gold is 19.3. So that's grams per milliliter. That's the unit you will often see for density. I would like to make a note that 1 milliliter is a cubic centimeter squared. So if you measure some regular object and you have it in cubic centimeters, then that's equivalent to a milliliter. All right, so I have three questions, starting with number 0. Okay, number 0 is just, okay, you're calculating a density. And you know, you've heard the formula before, right? Density equals mass over volume. What I'd like you to consider when you do problems is to think about the units, right? The unit of density is grams per milliliter. Therefore, if I see some question, this just says something, it's just some made up thing. Something has a volume of 45 milliliters and a mass of 37 grams. What is its density? And I just wrote density. It's like prom, right? Like so. 37 grams, 45 milliliters. I don't need a formula to solve this. I see the unit. I need grams in the numerator and milliliters in the denominator. So I write that 37 grams over 45 milliliters, and that's going to give me a density because the unit is right. So 37 divided by 45 is 0.822, and this should be 2 sig figs, so we'll do 0.822, 0.82 grams per milliliter. All right, next one. What's the mass of 25 cubic centimeters of gold? So, okay, I threw this in here. Well, 1 cubic centimeter equals 1 milliliter. So if you want to write the extra conversion, you can. I'll go ahead and write that. We have 25 cubic centimeters of gold. AU is the formula for gold. Well, okay, I could just put milliliters, right? Or I could write a conversion factor. So really either one. 1 cubic centimeter equals 1 milliliter. Okay, now I've got a unit of milliliters, right? This cancels out. We've got a unit of milliliters. I see a unit of milliliters in density, right? Grams per milliliter. This, for gold, it is 19.3 grams equals 1 milliliter. And I can make a fraction with, either of these can be in the numerator or denominator. So I have milliliters in the numerator. I'm trying to figure out the mass, right? I need grams as my final unit. So I'm going to make a fraction and I'm going to cancel out milliliters. So milliliters is going to go in the denominator and grams goes in the numerator. So I'm thinking about unit analysis as I do this, 19.3 per 1, and now I'll get my answer. Okay, so it's 25 times 9.3, 19.3. Maybe when you looked at that, you didn't need to think through all that, but this is how you use density as a conversion factor. 25 times 0.3 equals 482.5. We should have 3 sig figs for this, 2 sig figs for that, so we'll call it 480. I'll call it 480 grams. AU. All right, we get the gold. All right, and what is the volume of 175 grams of aluminum? All right, we have a density of aluminum. You can see it's much less than the density of gold. I've got some aluminum right here. You've got aluminum in your house. I don't know if it's refocusing. Maybe it will. So these are Japanese yen, and they're made of aluminum. If you were here, I could point it out to you and you tell me it feels like plastic. 175 grams of aluminum. Okay. 2.7 grams equals 1 milliliter. I'll write that. Where'd my blue marker go? Start in black. So that's how you make a conversion factor out of that, and either one can be in the numerator or denominator. I have grams in the numerator. I want volume, so I want milliliters in the numerator and grams in the denominator. 1 milliliter is 2.7 grams. So now I'm going to be dividing, And you're thinking about the units when you're doing this. So 175 divided by 2.7. I got 6.48 or 64.8. 64.8. However, my conversion factor only has 2 sig figs, so I'm going to be limiting my answer to 2 sig figs. So it should be 65 milliliters of aluminum.